Hello everyone, welcome to this new video. So in this video we are going to see how to do pre-processing in time series dataset. Okay, first let us create one Python file. This is Jupyter. So I'm going to create a Python file in Jupyter. So let me increase the size. So first of all, I'll be importing the packages that I'll be needing. Okay, I'll be needing numpy, so I'm writing import numpy as np, and I'll be needing pandas also. Okay, let's write it. Then I need to read my CSV file, so I'll just write down df equal to pd dot read. After that you can press tab so you can see the option. So read CSV. The name of my CSV file is ghy.csv. Make sure that you have uploaded your CSV file in Jupyter beforehand itself. Okay, now let's see how the dataset looks like. So if I give df.head, you can see we have date, then we have these data. These are basically pollution related data. Okay, PM 2.5, PM 10, nitrogen dioxide, sulfur dioxide, wind speed, wind direction, then solar radiation, barometer pressure, atmospheric temperature, and rainfall. Okay, now the date, if you see, I don't want it to be I want this date to be in the index. Okay, from that, so I will write down, I'll make it index column. So I'll write down index call, within colon I'll write down from date. Make sure that you spell the spelling correctly, otherwise it is not going to come. And I just need the date. So here time and all everything is there, so I'll just write down parse dates equal to true. Okay, true spelling is wrong, I need to make T as capital. Okay, now let's run it again. So now you see date has become the index. Now so this is the data that we have got. Okay, after writing this, now let's start the pre-processing. Okay, first of all let us see like what are the unique values for each of the features. Okay, so this will help us to see if there are anything other than any numerical values. So you see PM 2.5 contains only numerical values. So similarly we are going to check this for all the features. So I'll just write down PM10, then dot unique. So you see these are also numerical values. So likewise we are going to check for all the values. I'll just fast forward it. Now if you see for WS, it is containing numerical values, but if we go little bit up, you can see there is none. So this is not a numerical value. So we see that there are some other type of values also present in the columns. So if we see all the other features, we will find that none is present in many of the features. Okay, so this one wind direction doesn't have, but let's see what is the other one, SR BPAT. Okay, so next if we write SR, so it is containing this none values. So ultimately none value is present in the data set, so we need to do something about it. So we will be checking for all the other features also, just to check if there is anything other than none or something else is also there. So after getting checking all these things, we will get to know what exactly we need to do. It is very important to understand what values are there. So we have completed checking the unique values for all the features, and we found that we have numerical values and only none is there. Okay, so we need to do some pre-processing to it. So after finding the unique values, we will replace the none with 0. Okay, so this is the line we are going to write. Now wherever none is present in the data set, it will be converted to 0. Now we are going to find the information, basic information about the data set. So let's see df.info. If you see, so everything is in object, the data type is object. So first we need to change it to numerical or floating point. Okay, To change to numerical value, that is floating point value, I'm going to write down df pm 2.5. We will take the particular column or feature, then we'll just write down pd stands for pandas to numeric, and then again the column name. So likewise I'll write it for all the features. That is, we have total, I think, 11 or 9 features. That is, basically we in this particular problem, we want to find out the forecast the value of pm 2.5, particulate matter 2.5. This is air pollution data. So these are the features. First one is particulate matter 2.5, then particulate matter 10, nitrogen dioxide, sulfur dioxide. So one by one we will have to take all the features and change it to numerical value. Otherwise, if we keep it as object, so when we'll be applying the machine learning algorithms, it is not going to take the, it is not going to, we won't be able to apply the algorithms. So it is very necessary that we convert it to numerical form. In our dataset, we don't have any categorical values. If we had any categorical values, we would have to convert it to numerical values again. Maybe in another video, I'll show you how to convert categorical value to numerical value. So right now, I have converted almost all the features to numerical value. I cannot do it directly, so that's why I'm taking the features one by one and getting it converted. Just one more left. Okay, just I need to write down RF and it will be done. Okay, let's see. Now shift enter. So this has been converted to numerical value. Now if I write, now after converting it to numerical value, we will check the if there is any null values. Okay, null values means empty values. So I'll write down df dot is null sum. So we see that there are no null values in our data set. Okay, for each of the columns there are no null values. Now we will see if there are any zero values. Obviously it will be there. So but still let us check. So you see in PM 2.5, this many zero values are there. Okay, all the columns are having zero values. So apart from rainfall, see, rainfall can be zero, right? There may be no rainfall. But for the other features, that is temperature, PM 2.5, it cannot be zero. So obviously there are some, we need to do some pre-processing. Now since we have lots of zeros here, so we are going to convert all the zeros to nan. Okay. So I'm going to write df pm10 dot replace 0 np dot nan in place equal to true. Okay, so it is going to reflect in the database itself, datasets itself. Now I will be applying the same thing to all the features. So you see directly I'm copying pasting it apart except RF. Okay, so all the zeros will be replaced with nan values. Okay, let's press shift enter. So it has been replaced. Okay, now we need to convert the nan values to some, replace the nan values with some values. So we are going to do the imputation method using mean values. Okay, so suppose for PM 2.10 is there, suppose. So we are going to replace all the nan values with the mean of that particular PM10 values. Okay, that column. So we are going to write it like this. Now we are going to do this, do the same thing for all the other columns. So I'm just going to copy and paste it here. So all the nan values will be converted to mean of that particular columns. Okay. Now let us see whether we have nan values or not. Okay. So df equal to 0 dot, we will just write down sum x is equal to 0. Okay. Now if we write like this, since all the nan values had been, because first we converted the zero values to nan, then nan to the mean value. So now we don't have any zero values except rainfall. Now, so the data set is fair. We don't have any missing values in our data set. Now let us write down df.describe to see the description of the data. So total we have 33067 data or rows available. The mean for each of the columns, each of the features is given. So you can see the mean, standard deviation. Then we have standard deviation is deviation from the mean. Okay, Then mean, we have minimum. What is the minimum value? So you see rainfall is 0, minimum value 0. For rest of the columns we don't have any 0 values. So 25% quartile, then 50%, 75%, and the maximum value is also displayed. Now if we want to see any outliers, I'll just write down box plot equal to df dot box plot. Inside columns we need to give the column features name. So you can see these are the outliers, that is exceptional values for PM 2.5. Then for similarly for each and every values, these are the outliers, that is that doesn't fall in the usual range. Okay, so we need to do something to deal with the outliers also. You see for BP pressure, the outliers lies in the minimum side. For rest of the things it lies in the upper hand side. Okay, so in this way we can find out the outliers. Then after finding the outliers, we can see the plots of the different features also. Okay, so if we want to see the plot, we'll just write down df, within that give the name of the feature and that dot plot. So you see from 2019 to 2023, so this is the trend. So you can see from 2020 the concentration of PM 2.5 has reduced, maybe because of the COVID period. The pollution has gradually decreased. So before COVID, the temperature, the PM 2.5 concentration was quite high, right? So this way you can plot all the different types of graphs for each features and try to understand the data. So if we see for rainfall, if we plot the rainfall data, you see this is the rainfall data. So the using the graphs you can do many analysis. So that's all for today's video. So this is how you can perform data pre-processing in time series data. If you like the video, please do like and subscribe. Thank you.